Okay, the other important topic in design and analysis of algorithm is asymptotic notation. Asymptotic. Simply, it is a mathematical way to describe the growth rate of an algorithm. Actually, this topic is coming from mathematics, so it is a mathematical way to describe the growth rate of the algorithm. So this asymptotic notation means actually to it helps us, or we need to simple method to represent the time complexity that we write, instead of write the length or the length function just like previous one. We need to have the simple method to represent the time complexity, and it helps to find out the class of the algorithm so anyone can understand simply. There are notations used to describe running time function. There are different notations. The first one is big O notation, big omega notation, and theta notation. Theta notations. And there are also different notations, but today we will concentrate on those three different notations. So when we see the big O notation is a way of comparing algorithm and is used for computing the complexity of an algorithm. It is only concerned with what happened for very large value of n. Therefore, only the largest term in the expression or the function is needed. For example, if the number of operations in an algorithm is n squared minus 1, n is insignificant compared to n squared for large value of n. Hence, n term is ignored. Of course, for small one value of n, it may be important. However, big O is mainly concerned with large value of n. When we see the formal definitions of big O notation, so f of n is equal to big O of g of n if there exists c and n naught. It is subset of positive constants such as for all n greater than n naught, f of n less or equal to c of g of n. This is the definitions of big O notation. So based on this definition, let's see some examples, like if the time complexity or f of n is equal to 10n plus 5 and g of n is equal to n, shows that f of n is big of g of n. Let's see the above example in detail. So 10n f of n, which equal to 10n plus 5, right? 10n plus 5. So let's show that f of n is equal to big of n. Let's show that this one. So to do this, when we see the definitions of big O notation, f of n less or equal to c of g of n. So 10n plus 5 less or equal to c of g of n, right? So here we can simply add any function that should be greater than this function, right? This function. So 10n plus 5 less or equal to, let's let's try to add the function that is greater than this one. I mean, yeah, that is greater than this function, right? So we can add 10n plus 10n plus 10n plus 5n, 10n plus 5n, right? Then 10n plus 5n less or equal to 15n, right? 15n. So this is always true when the value of n greater than 1, right? Greater or equal to 1. So when we replace 1 in the at the value of n, so 10 plus 5, which is equal to 50, less or equal to 50. That is true. When we add the value of n is 2, it is obviously greater than this one. So this 15 is the value of c, and this n is the value of what? G of n. I mean, G of n. G of n. So this is f of x, I mean f of n. So f of n, which means in general, we can say that f of n, which equal to big of G of n, right? In the definition. In the definition, there is f of n which equal to big of G of n. So which equal to big of, add the value of G of n. G of n means n right here. So n. So f of n which equal to big of G of n. So we can do just like this. Let's see another example. 3n squared plus 4n plus 1. 3n squared plus 4n plus 1. So 3n squared plus 4n plus 1. 3n squared plus 4n plus 1. Plus 1. So let's show that f of n which equal to big of, I mean big of n square. Let's show that f of n which equal to big of n square. So we simply use the formula of big O notation. So f of n, I mean 3n square plus 4n plus 1 less or equal to c of c times G of n, right? C times G of n. So which means we will add any function. Actually, there is no a formula to do this, but we will use try and error methods. So 3n squared plus 4n plus 1 is equal to any function. So any function that's greater than this one can be used here. So simple, to make simple, we can use this constant, this function constant, and the highest power. So 3n squared plus 4n squared plus 1n squared, 1n squared. Actually, we have to use the single term here. We can't use multiple terms here. So we use n squared only. So less or equal to 3n squared plus 4n squared plus 1n squared. 7n squared plus 1, 8n squared. So less or equal to 8n squared. Which means 3n squared less or equal to, I mean 3n squared plus 4n plus 1 less or equal to 8n squared, right? When this will be true when the value of n greater or equal to 1, greater or equal to 1. So we can check by replacing the value of n here more than 1 value. So this means this one is the f of n, and this one is, this 8 is c, right? And this one is g of n, by using this formula, So which means f of n, which is equal to, we can define f of n which is equal to big of g of n. There is here, right, in the formula of big of notation, which means which is equal to big of, what is the value of g of n? G of n is n square. So f of n which is equal to big of n square, when the value of n is should greater than or equal to 1, and the value of c is what? The value of c is 8. So we can simply prove any time complexity for any algorithm just like this. So we can represent this time complexity class, or this time complexity class is belongs to n square. It is belongs to n square. Okay, this is how we use big O notations. Actually, there is a theorem for all the following theorems. Assume that f of n is a function of n and that k is an arbitrary constant. So the first theorem is k is big of n. If k is constant, then big O notation of k is big of 1. The second theorem is a polynomial is big of the term containing the highest power of n. For example, if we consider the previous one, 3n squared plus 4n plus 1, right? So this one, n squared is the highest power of, contains the highest power of n. So we will consider this one only. So polynomial growth rate is determined by the leading term. If f of n is polynomial of degree d, then f of n is big of n the power of d. In general, f of n is the big O of the dominant terms of f of n. Theorem 3, k times f of n is big of f of n. Constant factor may be ignored. It is not considered if there is a constant. For example, 7n the power of 4 plus 3n squared plus 5n plus 1000 is big of n the power of 4. When we see theorem 4, for any base b, log b of n is big of log n. So we simply ignore the base. All logarithms grow at the same rate. So we will consider, we will not consider the base one. The other notation is big omega notation. So big omega notation, it is provide an asymptotic lower bound. Actually, the big O notation provides the upper bound of the algorithm. It provides the upper bounds of the algorithm. We can define the big O notation, the big omega notation. A function f of n is big omega of g of n if there exists a constancy and n naught is the value of positive constant, such that f of n is greater than or equal to c times g of n for all n greater than n naught. So this is the formal definition of big omega notation. For example, if f of n is n squared, then f of n is big of n squared. You can say this one. In simple term, f of n which is equal to big of g of n means that the growth rate of f of n is greater than or equal to g of n. So actually we can prove f of n square is f of n big of n square, how it comes. So simply we can do that just like in the previous example, as we do in the big O notation. F of n, which is equal to n square, right? So to prove this one, big of n square, to find big of n square, so f of n greater or equal to c times g of n, right? C times g of n. So n square greater than or equal to c times g of n. So we can add here any function that should be greater, less than these f of n functions, or equal to. We can add equal to. So let's try n square greater or equal to 1 times n square, right? 1 times n square. So n square greater or equal to 1 times n square. So this one is when the value of n is what? When the value of n is 1. When the value of n is 1. So n square is greater or equal to 1 times n square. That is true. So this will be the possible answer. So this one is what? This one is c, the value of c, and this one is the value of d. The value of g of n, the value of g of n. So which means f of n, which is equal to omega of g of n. So f of n, which is equal to the value of g of n is n square. So f of n, which is equal to omega of n square. So we can prove just like this one. So which means any function less than n square is the possible answer for this one. The possible answer in case of omega notations. And the third one is theta notation. So a function f of n is belong to the set of theta of g of n if there exists a positive constant c1 and c2 such that it can be sandwiched between c1 g of n and c2 g of n for the sufficiently large value of n. So when we see the formal definition, if a function f of n is theta of g of n if there is both big of g of n and omega of g of n. In the other word, there is a constant c1 and c2 as well as k greater than 0, such that c1 g of n less or equal to f of n less or equal to c2 g of n for all n greater than or equal to k. If f of n is equal to theta of g of n, then g of n is an asymptotically tight bound for the function f of n. Now let's consider the previous example, or let's take this simple example, or simple f of n which is equal to 2n plus 1. Then let's prove f of n which is equal to theta of n. So to prove this one, f of n which is equal to 2n plus 1, right? 2n plus 1. So it should be tight bound between less or equal to c2 times g of n. and also let me rewrite again. So in the definition, C1 times G of n less or equal to f of n less or equal to C2 times G of n. So in the place of this function, or C1 times G of n, in this one, we should add the function that is less or equal to f of n only, less or equal to f of n. So to do this, we can simply 1n, 1 times n only, less or equal to f of n is 2n plus 1, 2n plus 1, less or equal to, we should write the function which is greater than this one, So 2n plus 5n, we can consider this one. So 1n less or equal to 2n plus 1 less or equal to 7n. So this is true when the value of n is greater than or equal to 1. So greater than or equal to 1. So this is a possible answer. So the value of C1 will be 1. This one is C1. And this can be C2. This can be C2, or we can simply, this one is C2, and this one is G of n, right? This one is G of n, and this one is G of n, and this one is f of n. So actually, instead of 7, we can replace with 3 also. It is true. When we replace 3, when we replace the value of C2 is 6, it is true. When we replace 5, it is true. And also when we replace 4, it's also true. And or when we replace 3, it's also true, or it is greater than this function. So we can make a 3n plus, 3n is the value of C2 of C2 of G of n. So it is here we will put the largest value and the largest function of f of n. So f of n, which is equal to theta of G of n. So which is equal to, what is the value of G of n? It is n, right? So simply we can put theta of G of n is equal to theta of n. So f of n, which is equal to theta of G of n. So this is all about today's lesson. Thank you for watching till one. See you later.